So in this video, I want to take a look at what it'll take to actually write physical floppies that we can boot the Altair 8800 from. I thought we'd start with a quick review of the hardware. Here's my 8800 system as put together. We've got the two SIO-JP card here in the front. It's got the two serial I/O ports for it that are on the same ports and same UARTs, etc. that was on the original 8800. Kind of a look down into the card cage as it stands here. We've got, of course, got the serial I/O card up front. We've got the floppy disk emulator here that emulates the Altair floppy disk controller. I've got a 50-pin ribbon cable coming off of it that goes around to the actual floppy drives. I've got three 16K RAM cards stacked here for 48K. I've got the reproduction CPU card sitting right here. Yeah, it's a CPU card, and in the back card here is the interface for the front panel we build out. So, it's a pretty complete system here. I've got a couple 360K double-sided, double-density floppy drives here. Really old-school PC floppy adapters. They're mounted into a little chassis here with the power supply in the back. It's got a standard 34-pin cable that comes out. That cable jumpers over to this little adapter board that came with the FDC Plus. So the 50-pin ribbon cable comes in here, and the 34-pin cable comes out. And this just does the translation of the wiring between the connectors. And of course, we have some physical media. I've got some just generic double-sided, double-density floppies here that we're going to attempt to write an OS onto. And finally, just a quick view of the front of the machine. So hopefully in this video we can go through all the steps of actually writing those physical floppies. So the next thing I want to take a look at is the configuration of the system to get these floppies created. So the first thing is the 882 SIO card here. And green in here are the default positions of jumpers for everything here except for the baud rate here. I've disabled the onboard ROM with the AMON monitor in it. And I've set both serial ports to 19,200 baud. So again, in red here are the things I need to do to make that work. If we go over to the FDC Plus card, I've disabled the onboard RAM on the card because I'm using those three 16K RAM cards in the system. The PROM is enabled. It's set to the default. And I've set the drive type over here on these switches to be direct connect to a 5 1/4 inch drive as Altair mini disk. So this is the configuration that'll talk to those 360K floppy drives and emulate the Altair mini disk system. Next thing I kind of wanted to peek here at, and this is the FDC Plus manual, is the FDC Plus has that monitor on board, which we have enabled, and there's multiple entry points into that ROM monitor. And the two we're concerned with is F800 that gets us into AltMon, and FF00 that is the combined bootloader that hopefully will boot from floppy. So these two addresses we need to keep in mind. And finally we get into the AltMon itself and the commands in it. We're going to be using the hex load command here. So this will load an Intel hex file, and the command is H and then either port 0 or 1. I have two TerraTerm sessions active here. This is on TTY0 on the machine, and this is on TTY1. So this is where we'll be actually seeing the software run, and we'll be doing the work to send like an Intel hex file to the machine over in this terminal. So the next step here is to get the Altair powered up and running. So let's go ahead and apply power to the system. We want to set the addresses here to F800. So we've got F8 on the switches, 0 and 0. Let me go ahead and just do a reset of the machine just to be sure. We want to examine that address so we start execution there. And now we want to run the AltMon. And hopefully over here in the terminal, we've got AltMon up, which we do. So the next thing I want to do here is I need to load a loader that'll be used to retrieve the file from the PC over the serial port and write it to an actual floppy. And so to load that, we're going to do a hex load. And I'm going to use TTY port 1. So we've got TTY port 0 and 1 here, and I'm going to use TTY port 1 to do this. And to do this, we're just going to send a file. Need to retrieve the file here, disk image transfer. And there'll be a PC to floppy hex file here. This is an Intel hex file. And if we send it, we can see it start to give us addresses over here as the file is being sent. And those are the addresses in memory that that program's being uploaded to. So let's let that continue to run here. It'll take that a bit to actually get that loaded into memory. I can see I can actually reposition this camera a little bit as well while that's running. If we, while that's running, let's go ahead and jump into FDC Plus. I'm trying to remember where that source is. No. Hex files, no. Where is the... Sorry for clicking randomly here. I do not remember where this image transfer. Let's go ahead and take the PC to flop hex file here and just open it in Notepad so you can get an idea what it looks like inside. This is an Intel hex file. It's got the load address, so this is loading an address 100 hex, and of course all of the bytes that get loaded up. So everything's loaded there. We've got the Intel hex file loaded into the machine. So now we want to start execution of that loader program. So we're going to come back over to the Altair. We're going to go ahead and stop the machine. We're going to set our load address to 0010. So that's the beginning address where the code got loaded. And go ahead and examine to set that as our address, and we have 0100. And let's go ahead and start execution at that address. And we should see the instructions come up here, and we did over here on TTY0. And I'm going to go ahead and write to drive 0. I don't know if you caught that, but the floppy drive woke up and came to life. Let me move the camera over here so you can get a view with a floppy. So the floppy drive has woke up. Let's go ahead and put a floppy in the drive. And I think the front panel will be more interesting to watch here. Try to get the front panel kind of displayed here. And I'm going to send the file via X terminal. So this is an X terminal send on port B or TTY 1. So I'm going to go ahead and put in the 2. And it says send an X modem file now, and we're going to send it from this window. So we're going to do a file, and we want to do a transfer via X modem send. And it's asking us here which file to send. And I'm going to go into CPM22. I'm going to pick the CPM 24K1 disk file. So this is the CPM for 24K in memory, and we can touch that up in a minute. So let's go ahead and select that file. And what we'll see here is X modem start to send that contents to the Altair. There's a little bit of activity on the LEDs, not a whole lot here, as that file gets sent up. And so this takes a bit. And there it goes. The floppy just started writing. We see lots of LED activity. If we come back over to the floppy drive, you can see it's being accessed. You might be able to hear the head stepping. It's written the first part that it sent up, and now it's sending up the second part. And it's writing that second part. So it's done. It believes we've written the file. I'm going to go ahead and exit out here. So we should hopefully have a bootable CPM22 file now. So let's come back over to the Altair. And remember, the second entry point in that ROM was FF00. That's where the combined bootloader lives. So we're going to set FF00. Let's go ahead and examine that address, since that's where the code starts running. And let's run it, and hopefully this will boot that floppy. I heard the head step. And there it is. We've booted CPM. So we were able to write CPM, and now we've actually booted from an actual floppy on the machine, which is really pretty slick. We can do a directory here. Let's go ahead and convert this to a 48K image. And to do that, we're going to do a move CPM5 is the program. We're going to tell it we have 48K of RAM. We now have that 48K of RAM image in memory. Now we're going to do a sysgen. Load sysgen off floppy. Source drive name, if we just hit enter here, it'll actually use the image that's in memory. I want to write that to drive A. I have the disk in drive A I want to write to. And really at that point we're done. Your best bet now is to reset and reboot the machine. So let's go ahead and stop, reset. We need to examine to get address FF00 where the combined bootloader lives. And let's go ahead and run that, and we should see the machine boot again here. And it now tells us we've got a 48K CPM image. That's really pretty cool. So let's go through and do one more disk image. So let's stop the machine, reset. We need to get back to Altmon, which is at F800. We'll run it. I should have the Altmon prompt. I'm going to put a second floppy in drive B. I'm going to spin this over here this time so you can see the drive and some of the LEDs flash. So we have a floppy in drive B as well. From Altmon, we're going to do a hex load off of TTY1 file. We're going to send a file in this case. Send file sends it as text, whereas Xmodem would send it encoded as Xmodem. We want to get back up here to the disk image transfer folder where I have this, and I'm going to send PC to flop hex. And this will run here again. While that's going, I've got too many files open. We can go ahead to the PC to flop assembly file. We can edit this in Notepad++. And this is the program that we're sending the Intel hex file over for. So this is the code here that is reading the floppy image off TTY1, in our case, and writing it to the actual floppy. And there's a lot of stuff going on in here. You could certainly spend time and read through this to understand how it works. My understanding is this is also CPM compatible, so that starting address this loads at, 0100 hex, is the normal place CPM loads a program for execution. And in my reading it says that you could run this as a CPM program as well, and that's what the COM file here is. It'd be a CPM application. So we'll let this keep cranking here. I'm sorry it takes a bit, even at 19,200 baud, it takes a bit to do all this. At 9,600 baud, everything's basically 4 times slower, or twice as slow. Let me take that back. Twice as slow. So it is loaded. Now we need to go back to the Altair, and I'm going to go ahead and stop it and do a reset. I want to set my address to 0100 01. I want to start execution there. That should fire up the loader. Back here on the terminal, I'm going to make the destination drive B, which is the second drive over there. It should have just came on, and it did. I'm going to once again Xmodem from TTY1 file. I don't want send file in this case. I want transfer, because we're going to use a format to send it rather than text. Xmodem send. Let's go back to CPM22, and there's a second disk here. And let's go ahead and open that and send it. And this takes a bit. And it's buffered it up, and it's now writing it to the B floppy. Now the downside of using these mini discs is there's not a lot of storage on them. It's treating it as a single-sided 35-track drive. I think about 60K of storage. Whereas 8-inch floppies give you 330K, I think. The next thing I'll tackle in this are 8-inch floppies. I've got 8-inch floppy drives in media, though I don't know if I can actually get it to work. I need power supplies and other stuff. So cool. That is done. Go ahead and stop the Altair. We're going to go back to address FF00 where that combined bootloader is. We're going to run the combined bootloader. I did that wrong. I actually need to examine that to set the address bus to FF00 and then run it from there. And we see it accessing the A floppy, and it did. And we can go to the B floppy. And we should find stuff on it. Is there anything on here I can actually run? Yeah, let's go back to the A floppy and format a disk while we're here. So there's A format, which is a replacement format utility. I need to do A format B colon. A format B colon. And we're going to pull out the disk that we just wrote that CPM disk 2 to. And let's just throw in a blank floppy here. Well, whatever was previously on it, floppy. Again, these were picked up surplus. And we've got a disk in the drive that's ready. And it's formatting the mini disk. So really things are working pretty well here. I'm actually impressed at how well this come together and how well the emulation is working so far. I don't want to format another. But CPM and disk A. Not really sure why it asked me that. Okay. We can play with A copy here. A copy, drive B equals drive A. And I believe that'll make a copy of disk A to B. We're ready to do the copy. And you can see it cranking away here. And I think this is doing a disk image copy, which means I should have a backup now of the bootable media. As I was saying, I'm really surprised how well this has come together. The FTC Plus board so far has worked really well. Without that board, I wouldn't be at this point. I'd still be looking for an actual Altair floppy controller, which appear to be unobtainium. So I've got CPM back in drive A. Pull that disk out. Hopefully this is now a bootable copy of it. We'll do a stop, reset, address FF00. And there it is, booting off the copy of the floppy. So, so without the FTC Plus, this would have been a lot more work if I could have ever found an Altair floppy controller. The 88 SIO2 reproduction, again, has just been invaluable in this, trying to find an actual 2SIO card, Altair card. There's two of them on eBay at over $400, which I will never spend for a card. So this is a good compromise. We've, in this series of videos so far, we have built a replica of the original 88 processor card. We've used some actual old school S100 cards for memory, and a couple of newer production cards in the front panel and everything. So I'm pretty happy with this. This is a pretty nice little build. So I think with all that said, I'll wrap this up and we'll talk soon.